Let's take a look at the 2018 AP Statistics exam, problem number 3, which relates to probability. So let's take a look and see what we have to say here. So the problem is describing that 3.5% of all children born in a certain region are from multiple births. So that means like twins, things like that. Okay, twins or triplets, those kinds of things. Of the children who were born in the region who are from multiple births, 22% are left-handed. You could think of that like a conditional probability if you wanted to. It's worth practicing that notation. So they're saying the probability of, and let's just take a look at this. I don't want to cover up too much. Try not to block your view here. So if we look at this, it says of the children from multiple births. So that's the subset of the population we're looking at. So when you think about a conditional probability, it means that that's sort of like your restriction. We're only looking at people who came from multiple births. We're saying 22% are left-handed. So the probability that someone is left-handed, given they're from a multiple birth, is 0.22. And then there's a second conditional probability given here. It says of the children in the region from single births, 11% are left-handed. So the probability of someone being a left-handed person, given it was a single birth, is 0.11. It's good to practice these notations. All right, part A. What's the probability that a randomly selected child in the region is left-handed? So we just want the probability that someone is left-handed. Now you'll notice this probability that I wrote in green is not conditional. They're talking about anyone being left-handed. So you have to consider two cases, right? Someone could be left-handed and come from the group of people who are multiple birth children, or a twin, or a triplet, and someone could be left-handed and be just a single birth child. All right, so let's see what we have here. It looks like 3.5% of the children are from multiple births. So what we'll do is we'll look at the probability of multiple births, which is 3.5% or 0.035. And out of those, we want the left-handed people. So we're going to multiply that by the probability of left-handed given multiple births. So that's times 0.22. And then there's another group you need to add to this. You need to worry about the people who were single births and left-handed. So we'll say plus. So I'll put a big plus here. And let's write this way. So 96.5% of the people are single births. That's because 3.5% over here are multiple births. So that's the probability of a single birth times the probability one of those people are left-handed. So times the probability of left-handed given single birth. That's what you have here. So these two things need to be added together. So if we do that, we end up with 0.035 times 0.22 plus 0.965 times 0.11. So we'll say we type that into our T84, and we would get 0.11385. Okay, so that's that. By the way, if you're interested, it's not something that's tested directly on the AP exam. It is indirectly tested. When you add together these two probabilities to find the total likelihood that someone could be left-handed, you'll notice you're doing that by picking different subsets of the population. You're looking at the subset of people who were, oh, sorry, let's highlight the correct thing, that were multiple births, and then another subset of people who were discrete from that other group who are from single births. And then in each case, you're multiplying by the relative probability of someone being left-handed within those groups. And then you're adding them together when you're done. And that's sort of the key there. When you're adding them together with this plus sign in the middle here, sometimes they call this the law of total probability. So law of total probability. It's a lot of words, but I think if you think from a common sense point of view, it's probably better. You've got left-handed people who are from multiple births. You have left-handed people from single births. Find those two separate percentages and add them together to find the total number of left-handed people. Okay, let's take a look at the next question. And I think to do this, I'm going to copy this question and take it to a new page because I wrote all over it. Let's do that. Okay, there we are. And so what are they telling us here? They're saying in part B here, what's the probability that a left-handed person, what is the probability that a child selected born in the region is from a multiple birth, given the child is left-handed? So that they're asking specifically for a conditional probability, and the conditional probability they want there is the probability that someone's from multiple birth, given we know they're left-handed. Okay, that's the opposite of the probability given in the problem, just so we're clear. At the beginning of the problem, they said 3.5, approximately 3.5% of children from multiple births. Of children born in the region from multiple births, 22% are left-handed. So that probability is the probability of left-handed given multiple births. And here, the probability we're looking for is sort of in the opposite order. It's a very common thing to ask about on the AP exam, and it's from a famous theorem called Bayes' theorem. Okay, so how do you do it? By definition, the conditional probability is the probability of being from a multiple birth and being left-handed divided by the probability of being left-handed. Now, in part A, you found already that probability, so it was 0.11385. This is a problem where when they grade, they would be consistent in the sense that if you had the wrong answer for part A but used it correctly here in the denominator, you could still end up getting full credit for the problem. The probability being from a multiple birth and being left-handed is 0.035 times 0.1. That's not correct. 0.22. Let's erase that, make it clear. Sorry about that. 0.22. So all we're going to do now is multiply and divide. So if we take the time to do that, we end up getting around about 0.0676, something like that. Okay, let's look. We got one more part of this question to go. In typical AP style, one thing they like to do is take what you know about probability and mix it together with some other ideas from probability. So in this case, you'll notice they say a random sample of 20 children will be selected. So we sort of a fixed number of people. I think of that like a sample size, n equals 20. And then they say, what's the probability in the sample that will have at least 3 children who are left-handed? So if you think about it, we want a certain number of successes. We want at least 3 children out of 20 to be left-handed. And whenever you see that kind of question where they have a certain number of successes they want to see within a fixed number of trials, you know that you're in for something binomial. Okay, so let's make a variable. I'm going to let x be the number of left-handed people in the sample of size 20. And so if we continue, what we really want is we want the probability that x is at least 3. Now, if you know something about the T84, the T84 can easily do the following. There's 2 buttons in there you really care about. One of them is called Binomial Cdf, and usually it wants an N, a P, and a K, where N is the number of trials, P is the probability of success on each individual trial, and K is the number of successes that you want. Whenever you use CDF, then this equals the probability x is less than or equal to k. So what you should notice is that does not match the direction we want here. This is greater than or equal to, this is less than or equal to. So we need to rewrite this probability. And we can do that by saying, what's the opposite event of having 3 or more people be left-handed? Well, the opposite event would be the probability that x is less than 3, that we had less than 3 people be left-handed. Now, the calculator won't do that for us. It only does less than or equal to. So we want to change this to 1 minus the probability x is less than or equal to 2. So that's going to be it. That's what we're going to do. We're going to do 1 minus the binomial Cdf. You put n first, 20. P, the probability of someone being left-handed, that was 0.11385. And K, which is 2. So we're just going to type this in. If you forgot where binomial PDF is, on your TI-84 calculator, you want to go to something called second distributions or second VARs. There's a button on the front that says VARS, and above it is the letters DISTR. You want to find that. It's going to ask you for the number of trials. That's going to be 20. Probability someone's left-handed from this region is your answer to part A, which was 0.11385. We want to have 2 in there. And you do 1 minus, and to do this all correctly, you're going to get 0.402. Looks like a 1. Usually I write 4 decimal places. Okay, that's just about do it. Very popular thing to put a binomial probability inside of another probability question. Thanks for watching.